All of the MAC protocols that have been discussed so far, such as CSMA and Aloha, are applied for wired LANs. Those protocols cannot be used in wireless LANs due to the nature of a wireless LAN that uses short radio waves. Due to two problems, hidden and exposed terminals, conventional MAC protocols cannot be used in wireless environments. The simplest approach to dealing with problem of multiple access is to use CSMA method, which is used in wired LANs. A transmitting station should listen for other transmissions and only send if no one else is doing so. But there is no wire in wireless networks, and nodes might be within each other's coverage ranges. First, consider what happens when A is transmitting to B. If C senses the channel, it will not hear A because A is out of range. So it will falsely conclude that it can transmit to B. If C starts transmitting, it will interfere at B, which results in collision at B. The problem of a station not being able to detect a potential competitor because it is far away is called hidden terminal. Now let's consider the reverse situation. B is transmitting to A. If C senses the channel, it will hear an ongoing transmission, and it will falsely conclude that it is not allowed to send to D, while the channel between C and D is free. This problem happens because nodes are within each other's range. To solve hidden and exposed terminal issues in wireless networks, CSMA-CA, or Carrier Sense Multiple Access Collision Avoidance, was developed. The basic idea behind it is for the sender to stimulate the receiver to send out a frame, so nearby stations can detect this transmission and avoid sending data for the duration of the upcoming data frame. The sender sends a request to send, or RTS, and if the receiver is ready to receive the data, it will acknowledge the RTS with a clear to send, or CTS. If the CTS is received by the sender, it can start its transmission. This way, sender and receiver in a wireless node can avoid a collision. As shown in this picture, any station hearing the RTS is close to A, and it must remain silent for the CTS to be transmitted back to A without collision. Any station hearing the CTS is close to B, and it must remain silent during the upcoming data transmission. The chance of collision still exists, but it is very low.